Hello, my name is Phil Harris. I'm the founder at Insight Analytical. Some of you may know me from having been teaching sample system courses for the last decade, and I used to do these all over the world. Well, what I want to talk to you a little bit about today is a free online training that we're going to make available to people all over the world called Introduction to Sample Systems. Intro to Sample Systems is going to be put on as an online course that is going to cover all of the major considerations that one has to undertake when designing an analyzer sample system. We're going to begin with a session that talks about the inputs to our design. So what do we need to know about the process chemistry, and the application in order for us to even think about designing a good sample system? We're then going to talk about the general requirements of sampling, which of course one of is that we have to get useful numbers. They have to be useful to the person who needs those numbers. We have to get those in a safe and reliable way, so we have to ensure the sample is compatible with the analyzer and our sample system components. And then we have to consider, are we getting those numbers in a timely manner that allows us to do the kind of control we need? Once we've covered the fundamentals, we're going to delve into some subjects more deeply. So we're going to talk about flow and time delays. We'll talk about the fundamentals of time delay and how flow rate affects that, and then go through a number of delay calculations so we can see how do we actually estimate time delays in our sample systems. From the time delay numbers and the flow rates we get and the time responses, we'll be able to go into calculating pressure drops and how much pressure drop we're going to see in the sample system. And then we'll talk about flow and pressure and control and how we implement that in our analyzer sample systems. From there, we're going to move on to talking about phase behavior. So phase is important because our gas analyzers want to see gas phase samples. Our liquids analyzers want to see liquid phase samples. So we're going to talk about phase diagrams and how we can determine what temperatures and pressures will cause changes in the phase behavior of the sample. We'll talk about water and condensation in our sample systems and how to prevent that from happening. We'll talk about how phase changes can have a very negative impact on whether we're getting useful numbers. It can change whether we have a representative sample. And then we're going to talk about forcing phase changes, like vaporizing liquid samples. From there, we're going to move on to an important subject in sample transport, and we'll spend a fair bit of time discussing adsorption and desorption effects and how that happens on material surfaces and what we can do about it. We'll talk about sample extraction and where we put our sample probes, our nozzles, our sample taps, and how we get a sample out of the process and beginning its route on moving over to the analyzer. Two very important subjects that come up in analyzer sample systems are how we deal with liquids and particulates. And so if we have liquid droplets in our gas phase samples, we have to find a way to remove those. So we'll talk about coalescers, coolers, condensers, knockout pots, what things we can do to control the liquids content, especially in our gas phase samples. And then we'll also talk about filtration and what we can do to control the particulate content. So how we get particles out of the system. And we'll discuss what types of filters we use, how they work, and what we need to consider when we're designing a filtration system. After we've covered all of those subjects, we'll be able to start talking about full sample conditioning systems and some of the other parts of them, like remote stations or field stations, fast loops, stream switchings, and some general layout considerations that impact how our sample systems work. And then we'll touch on some very specific applications, like emissions monitoring or refinery liquids monitoring, distillation towers. Intro to Sample Systems is going to be set up as an online course. We're going to run it through both Zoom and LinkedIn Live. It will be approximately 16 two-hour sessions. That's including questions. So we'll do about 60 to 90 minutes of content in each session. When you sign up for a session, the slides and other content will be made available to you by email. And we're going to teach this course in 3 separate time zones. So we're going to teach it at 1 p.m. Central Standard Time. And this will make it be, of course, the middle of the day for our colleagues in North America and South America. We're going to teach it at 7 a.m. Central Standard Time. which will be the afternoon for our colleagues in Europe and the Middle East. And we're going to teach it at 7 p.m. Central Standard Time, which will be morning in Asia Pacific. So we're going to make this available to people all over the world. All of the sessions will be recorded. The recordings will be hosted on our website. And so if you're interested in signing up for the course or finding out more, go check out our website at www.insightanalytical.com and take a look at the education page. Thanks very much. Hope to see you there.